Hello everybody, this is a game development session in the USteam Virtual Camp organized by Shiva Robotics Academy in collaboration with the City of Jacksonville. Thank you for inviting me here. I am Adina. My name as a teacher on Scratch is Teacher Adina Satya. I teach coding amongst other things, and I like to teach online Scratch classes usually once a week, but also in events and in camps like this. Today, I'll give a session to teach you how to use Scratch to build an interactive game. I'm sure some of you are familiar with Scratch. So today we'll demonstrate building a game from scratch, so to speak, without remixing anything. We'll build it from scratch. And we'll start with a simple game, and we'll learn to add difficulty to your game in stages. Therefore, the game will be functional in the simple form to demonstrate, and then we'll keep adding new features to it. The session today is for the students in the elementary, so the 3rd, 4th, and 5th grades. Therefore, I start with a kind of a classic game. For popular demand, we chose the Pong game. And I already built the game together with my son, George. So again, this is a teamwork. I always work together with George Taylor, my son, who's a 12 years old, dedicated coder and game developer. And we developed a Pong game at the request of Coach K, of course, in 2 versions. One of them is single player, and the second one is multiplayer edition. And I would like to just demonstrate briefly how they work before we start rebuilding it from scratch, from the very, very zero base. The Pong game is practically similar to a classic game of Pong, of course, in which you play with a pedal and you try to catch a ball. And what happens is that the goal of the game is to keep the sprite from getting past you. We'll try one more time, paying a bit more attention to it. I will let it fall now. The game is over, which means I lost, if the ball touches a red line, which means it passed by my paddle. In the second version, the Pong game multiplayer edition, we added a new player to the game. So this is kind of difficult to play by myself. As you can see here in the instructions, we use arrow keys left and right for the player 1 and A and D keys for the player 2. So in this case, we have 2 players with 2 pedals competing. They have different scores here, and we are accumulating a point every time when we catch the ball with a pedal. We don't let the ball go past and touch the red ball. The opposite player earns a point every time we lose and the ball touches a red line on our side. We also have a timer here, and we timed this game, so we'll keep on playing for 60 seconds. Of course, this can be modified. So this is one way of playing a Pong game as a multiplayer edition. This is more complex, of course, than the first single player edition. Now, the way we start these games is by building a very simple game in which we only focus on the game mechanics, just the basic game mechanics, and then we add extended features to it. So let's talk about it a little bit in more details. After we complete a simple game that works, we plan to add those extended features. And this could be a score, a menu, restart, multiplayer, levels, rewards, timer. So these are the most common extended features that can be added to the basic game in Scratch. Now let's see what they mean. Adding a score to the game, we will learn about variables, and we find the make a variable button in data category. We'll name the variable and we'll add it to the game. We'll learn about using data with that occasion, and we'll do the same when we decide to add a timer to the game. Ideally, we'll set a timer including the game using variables. When we add a menu to the game, we have the possibility to include some directions, to write some directions on the screen, and include a start button at the beginning of the game. Optionally, instead of a start button, we can add a start key, so we can press a key to start the game. Then we have restart, extended feature. We can add a restart button or a restart key to start the game all over instead of needing to close the game and then use a green flag for that. Multiplayer is a more complex feature. There will be 2 players in a game or more, and there will be competing scores that will display on the screen. Adding a level to the game is again a more complex feature. We can use different back for changing the levels, and then we'll broadcast messages to trigger the next level, and we'll have broadcasting blocks, messaging from one level to the next. The rewards allow us to collect items, quest items, using the mouse or the arrow keys, classically. It is a very commonly used extended feature in a Scratch game. So again, score, menu, restart, multiplayer, levels, rewards, timer are those extended features that we commonly use to make the game a little bit more difficult. Now, adding difficulty in Scratch, what actually it means is that we add advanced concepts related to interactivity. This can be sensing, for example. So we are going to work with sensing today. We start using the variable and introduce a computational concept of data in relation to it. And we start using conditionals and operators. But that doesn't mean that we'll just learn about computational concepts. No, Scratch is about having a lot of fun when we work. So the important thing is that we will use these concepts in a meaningful and concrete way that will allow us to practically understand what these concepts do. And then we'll find motivating ways to use them in a fun work and in a very personalized game. You make the game look the way you want it to be. Start building the game. So we create a new project. We can name it Simple Pong Game. 1 player in the first version. Remove this sprite. I like to start with choosing the backdrop. It has to be simple, plain backdrop. Blue sky is pretty good. Blue sky 2. Then we have the brick walls here, 2 versions of wall 1, wall 2. They work. I'm going to choose stars. That's my favorite. And we need 3 sprites, a ball for the user to play with. I'm going to choose button 1. And we rename it as ball. It is too big here, so we can resize it right here in size. We make it 50%. Then we need a pedal for the user to control. I'm going to choose button 2. Again, we'll rename it as player 1. Even if we only have 1 player, we'll call it player 1 now. And I'm actually going to position them. The ball will go right in the center. You can see here X axis and Y axis. I'm going to find the point 0, but actually we'll get that by coding. It's easier. Somewhere in the middle of the screen. and we'll choose a precise location in the code. And then I'm going to pick the red line, which will be set to the point where we know the game is over. If the ball touches the red line, the game is over. It makes the sprites appear on the screen when we press a green flag. So this will be the first piece of code that we are going to write. We start with a ball. We need an event, of course. We start when the green flag is clicked. We choose show from looks. And we set the location. Go to the points 0, 0. Now, of course, we can duplicate the code for player 1. Player 1 here should be a little bit wider. I'll make it 120%. Okay. Again, when the green flag is clicked to show, and the position will be, X will be 0 again, because we want it to be kind of in the middle. And the Y will be minus 150. That will work. Then we go to the red line. And this will be a bit lower. I'll make it 175. For the ball, we need one more thing. We need to turn it 45 degrees. So when the game starts, the ball will start moving in diagonal. So we can save, and let's see what we have now. They just go in the right positions. Next, we'll make the pedal sprite interactive to be able to move it left and right to the arrow keys. So I open player 1, and there is a simple way of doing it, and I'll show you the simple way, but then I'll show you a more complex way that gives better functionality to the game. So for the simple way, we choose an event when the right arrow is pressed, and we choose for motion, move 10 steps. Then when left arrow is pressed, we move minus 10 steps. And of course, this will work basically, but see, normally we have to click every time we move multiple times. Or if I try to hold the arrow, you can see it doesn't go smooth. The movement is not smooth. There is a delay between clicking one time and pressing it for continual movement. And this can be quite dramatic in games, especially if you have multiplayers. So I'll show you a different way of doing this, because the goal here is to be able to keep the arrow key pressed instead of clicking multiple times. I want the pedal to move to the side, to the right, as long as we keep the arrow pressed. And the pedal will only stop moving when we release the arrow key, but we want to do it in a smooth way with better game mechanics. So what I'll do is to first remove the old key, the old code. And this gives us the opportunity to also learn more about control blocks. So what I'll do is to use the control block to repeat a repeat loop. But we don't want to state how many times we repeat, but we want a repeat until this block. Repeat until. There will be a condition here that will set, and the sequence of code we include here will repeat until this condition becomes true. Let's talk a bit about how loops and conditionals work in Scratch. First of all, the loops are used to run the same sequence of code multiple times. That gives us control to decide how many times we want the code to repeat and when to stop. So the loop will practically stop when we tell it to stop, when we program it to stop. The conditionals in Scratch allow us to make those decisions based on conditions, like for example, the decision on when to stop a loop or for how long we want the loop to run. And logic is used to determine whether a condition is true or false. And that's when we talk about logical expressions, building logical expressions. The loop will repeat the action if the condition provided is true, and the loop will end as soon as the condition becomes false. We are talking now about control blocks that repeat code. You can see the light orange color. This is exactly how they look in Scratch. You find that light color control category of scripts. I call them blocks, they call scripts. So in Scratch, repeat blocks are used to control for how long or how many times the code will be repeated. And we have three options: to repeat the code a number of times, which we can set, to let it repeat forever, it never ends, or repeats code based on a condition. We find the control blocks which check a Boolean condition for repeating the code in the same category, or they make another decision about what the code will do based on a condition in the same orange control category. And I chose these 4 blocks to explain today because we are going to use them a lot in this coding session. Wait until, repeat until, if then, and if then else. So let's see what these blocks do. Wait until waits until a condition becomes true before the following code can be executed. So it does nothing before the condition becomes true. It just waits. Once the condition that we'll include in this shape here becomes true, then it starts running the code that follows. Repeat until is a loop. As we can see again, this is how the loop works, and there is a repeat button here. We will include the condition, and it repeats the sequence until the condition becomes true. So it repeats a sequence of code till it finally complete that condition. If then is a Boolean conditional. We'll have a condition included here again. If the condition is true, the code within the if then block is executed. If the condition is false, there are no instructions on this path to follow. So we only have one option. If this condition is true, then the code will include in this block will run. We don't have a condition for the case it is false. In the next case, we have more than one condition, if then else. It gives more than one option. If the condition is true, the code within if then block is executed. If the condition is false, the else block is executed. So we'll have 2 pieces of code here, 2 sequences of code. And if the condition is true, we'll run the first one. Else, if the condition is false, we'll run the next one. Use operators and sensing in Scratch to build the logical expressions that we need for creating those Boolean conditions, the conditions that return a result that will be true or false. These blocks, you'll find them in Scratch again. I color them practically like those categories. The green category will provide all the operators, and the blue category will provide the sensing. These are very, very important, and we are going to use them in the session today. So we repeat the code, move 10 steps until this condition becomes true. So we have to build this condition. So what we want is practically to keep moving until the arrow key is released, so it is not pressed anymore. We have something interesting in the sensing category that we talked about earlier. We have key pressed. replace space here with right arrow key. So this makes a condition: if the right arrow is pressed, do something. However, we need a condition that tells us what happens when the arrow key is not pressed anymore. For this, look in the operators. We talked about this category as well, and we have this not, a conditional blot not, which is very useful. So we include this condition inside not, and what we get now is when the key arrow is not pressed anymore. So not key arrow pressed. And this is a practical example of how we could use sensing and operators to create a condition for the logical repeat loop. It is a logical expression. We include it in the repeat code. So what happens now again is that we build a conditional repeat until loop that will repeat moving the pedal 10 steps to the side until the arrow key is not pressed anymore. And of course, we want to repeat this code for left arrow and make it minus 10 steps. And these two blocks put together will include in a forever loop. We can link this to the first sequence. And now we have a very, very smooth movement. Next, we'll build the code to control the ball. So we move to the ball window. The easiest part, so the ball keeps moving and it interacts with the pedal on the walls. The easiest part of this is when it touches the walls, left and right and the top, it just bounces back. So we'll go to the motion category, we choose move 10 steps. If on edge bounce, in the control we make it a forever loop. And we'll give it a waiting time of 1 second before it starts moving. Then we can link it to the code so it is triggered by the green flag being clicked. If the ball touches the red line, then that's game over, so stop the game. We use stop all. For the condition, we use a control conditioner loop, if then. And the action will be to stop all. Now, for the condition, will be touching the line. For that, we can use a block from sensing, touching, and we'll choose the line. If the ball touches a pedal, we'll use another if-then loop. We'll get the condition touching play on. And what is it going to do? It will move 10 steps, but in random directions. So we'll say turn, and it's not going 15 degrees, it's going to be an operator that allows us to pick random direction. And let's say between 160 and 200 degrees. Link together, and I'll include it in a forever loop. And again, the event that triggers it is when green flag is clicked. The code works. Now it would be nice to include sounds in the games. So I'm going to choose 3 sounds. One of them I chose coin, that sounds very well when the pedal is touched. Here it is. So I'm doing this one. Then we choose another one that sounds good when the red line is touched, that's oops. Here goes. So we'll touch this one, we'll choose this one. And one more show at the end that the game is over. We tried a few sounds and I think this loo sound sounds better than everything else I tried. Here. I'll choose a sound. Okay. If touching player 1, we'll include start sound, and that would be coin. Then if touching the red line, let's play the sound oops, and then we'll play the sound loose until done. Another thing we have to do is to create a game over sprite, so it actually shows the text on screen when the game is over. And for that we need to build our own sprite. Sorry, we are not choosing a sprite, we are building one, so I have to choose the brush. And here is going to be a text, and we just write over. We'll make it really large to appear all over the screen. We center it, actually it's going to be a bit slightly. And it's going to be red. And save. Of course, a nicer way to be pixelated and everything, the look can be improved, but for now this will be our game over sprite. And we start coding it. We'll use broadcasting a message, so I choose from the events. When I receive new message, that's going to be over, game over. And show. But this message will be received for ball. So we'll have to broadcast game over if the red line is touched. Okay. Now we have to also reposition the game over message. So let's give in coordinates. It will go directly to the center of the screen, 0 and 0 coordinates to show. And we have to make it hide when the game starts. So when I click the green flag, hide. It will be the opposite for the sprites. So the other sprites show up when the green flag is clicked, but they will have to hide when the message game over is received. When I receive game over, hide. And the same message will appear. We can copy it this way in player 1 and in line. Here it goes. We'll align the code a little bit later. Let's try the game now. Okay. Now let's play again. All right. So it works. Now another element we need to add is a score, and once we have the score we can say it's a complete game in a more basic form without other extended features in the first version of this demonstration. For the score we have to make a variable, so we go to the variable section make a variable score for all sprites. Then we go to the ball. We set the variable score to 0 when the game starts. So we start the game with 0 points. And then we change the variable score by 1. We increase the score by 1 every time when the pedal is touched. The pedal catches a ball. Then we move to the player. We show the variable at the beginning of the game. And we hide the variable at the end of the game. So games are one way to make the usefulness of variables more concrete. And this is what we talked about when we mentioned the computational concepts. Let's try to play the game again. We have a score now. Let's make it this time. Green flag to start. So that's it. We have a game. So this is a shorter form of the Pong game. This is the first part of the video demonstration for creating single-player Pong game. In the next part, we'll add a menu and a restart button. And probably the third part will create a multiplayer edition of the game. I would like to go through a short review of the computational thinking and computational concepts, the way they were defined by the Scratch team at Harvard University and MIT. Here are the series of definitions they provided, and you will recognize them now from your practical experience in Scratch coding. The sequence, identifying a series of steps for a task. The loops, running the same sequence multiple times. Parallelism, making things happen at the same time. So you could see that we could run different scripts and different sequences of code in the same time, in parallel. Events, those are the things that cause another thing to happen. One thing triggers another thing to happen. Conditionals, making decisions based on conditions. Operators, support for mathematical and logical expressions. And data for storing, retrieving, and updating values. And at this point, I'm sure they do not sound very complicated anymore. They don't sound so abstract anymore because you use them hands-on experience in Scratch. And this is exactly the purpose of Scratch, to allow us to understand these computational concepts in a practical way by just implementing them in games and having fun. These are the website addresses of Harvard educational team. CT means computational thinking, where they provide the definitions and a lot more information about how they understand these concepts. And further, just to finish, I would like to remind you the 6 rules of Scratch. Be respectful, be constructive, share, keep personal information private, help keep the site friendly, and have a lot of fun. Keep scratching. Just explore, experiment, and learn as you go. And if you liked the session today, my teacher account again is Teacher Adina. You will not find it in the normal Scratch system. It is on a different system, which is only for teachers. It is a teaching system. But you can find it on the link provided below. That's where my online classes are. And again, my assistant teacher is my son, George, who's 12 years old now. And he is also the person who helps me recording the video and editing it today. Thank you for attending this session, and I hope you liked it.